So there are four things that we really want to make sure are clear in terms of things that you probably learned in a previous trigonometry class, but that we're going to use all the time in physics courses. And so all those build around four basic parameters with right triangles. So of course a right triangle is a triangle that has a right angle, a 90-degree angle. In this case, that happens to be this this 90-degree angle in the lower left-hand corner of the triangle. And so again, just to be clear, if our right angle is in this lower left corner, then A and B are the legs of the triangle because they're the ones that are adjacent to the right angle, right? They're the two sides of the triangle that come together to form that right angle. C is the hypotenuse of the triangle because it's opposite the right angle. So it's the one that's on the opposite side of the triangle from the right angle. And so the first of the parameters in terms of having defined A and B as the legs and C as the hypotenuse, the first parameter that we want to make sure that you guys remember is the Pythagorean theorem. So A squared plus B squared equals C squared. We're going to rewrite, because in this class what we'll often end up using is we'll end up solving for what basically will be the hypotenuse side by taking C equals the square root of A squared plus B squared. So this is the Pythagorean theorem, and it's going to help us relate the distances of two sides of that triangle to the third. And in our case, typically that third one's going to be the hypotenuse. So the other three things that we want to make sure everybody's clear about are the basic trigonometric functions. So to start with, I'm going to define an angle theta, and here you can see I've drawn an angle theta as this angle in the lower right-hand corner of the triangle, which again now means that I can define side A to be the one that's adjacent. So theta is drawn between side A and the hypotenuse. Side B is now opposite to the angle theta. So A is the one that theta is drawn between, so it's the adjacent leg. B is opposite. It doesn't touch the angle theta where it's drawn in the triangle. So now that I've sort of labeled the adjacent side, the opposite side, and the hypotenuse, again, I can just remember that the definitions for cosine theta are it's the adjacent side to the angle theta divided by the hypotenuse. In this case, that's side A divided by side C. Sine theta is the opposite side to angle theta divided by the hypotenuse, so this would be B over C. And tangent theta is the opposite side to the angle theta divided by the adjacent side to the angle theta. In this case, that's going to be B over A. So here are the three, again, the definitions for the three trigonometric functions that we want to make sure that we're comfortable with as well. Now, I could have picked a different angle, right? I happened to chose theta at the beginning. I could have picked the other angle. In this case, I'll label it phi. And again, what you'll notice is it changes, if I pick phi, it changes what the adjacent and opposite sides of the triangle are. So the hypotenuse is still the same, but B is now the side that's adjacent to the angle phi. A is opposite the angle phi. And so again, if I think about the cosine of phi, again, that's the same definition. I want adjacent to the angle phi over the hypotenuse. So in this case, that's B over C. The sine of angle phi, opposite to the angle phi divided by the hypotenuse, that's A over C. Tangent to the angle phi is opposite over adjacent. So I want the side that's opposite to the angle phi divided by the side that's adjacent to the angle phi. And so in this case, that's A over B. So what you notice is the cosine of theta is equal to the sine of phi. And that's true for any time your two angles add up to be 90 degrees. The sine of theta is equal to the cosine of phi. And so again, that's simply a function of the fact that theta and phi add up to be 90 degrees, so their cosines and sines have to be related in that particular way.